in this video clip, we want to use factor theorem to determine whether the given factor x minus c is a factor of f of x. Here again, x plus 5 is x minus negative 5. We want to know what is the meaning for factor theorem first. Okay, we know very easily to see 8 divided by 2 is 4. 2 times 4 is 8. You do the subtraction, you have a 0, that's the remainder. So then you know 8 can be written as 2 times 4 plus 0, because remainder is 0. So then you know the divisor is a factor of 8. Of course, 4 is the factor, but here mostly we concern is if 2 is a factor, because 2 was a divisor. Here we want to know if this one is a divisor or not. But we know if this one, we want to know if this one is a factor or not. So based on the observation right here, if x minus negative 5 is a factor of f of x, then x minus negative 5 as a divisor should divide f of x into it. Okay. Should divide f of x into it. Okay? So that means the remainder of f of x divided by x minus negative 5 should be 0. How to find remainder? How to find remainder? The answer we had already by remainder theorem. We did before. So how to find it? We plug in f of negative 5 to check if we got 0 or not. If we get remainder is 0, we can conclude x minus 5 will be a factor. Okay? So you plug in, you have a negative 5 cubed plus 3 times negative 5 squared minus 8 times negative 5 plus 10. Okay. Now what do we get? Negative 5, negative 5, negative 5, 3 times negative 125. Negative 5 squared, 25 positive. And then you will have is negative 75, or positive, because it's doubled, even square. Put negative, negative, you get a positive. So here you will have what? 40. And then plus 10. Is this together going to be positive 125? Yeah. 75 plus 10 is positive 85 plus 40, 125. So here what? Remainder. Remainder is 0. Okay. Then this tells us what? This tells us that x minus negative 5, or let's say that equals x plus 5, is a factor. Is a factor means what? Means this one can be written as x minus negative 5 times another one factor, q of x. Okay, or you may say x plus 5 times q of x. That means this expression can be written in this way. Okay, yeah, that's the meaning for factor theorem. Is if you plug in negative 5, you have a 0, then the expression, this one, can be written in this way. That is really true, because if you have this expression can be written in this way, you plug in negative 5 here, negative 5 plus 5, you got 0. Whatever this q of x is, you got 0. So basically, we actually explained the factor theorem. But you know, if any function can be written in this way, you know, you plug in 5, you will have a 0. Okay, so later on, in order to see if this is a factor, plug in negative 5 to see if it's 0. If it's 0, it's a factor. If it is not 0, not a factor. Here, the answer, you should say what? Yes. Yes, that x plus 5 is a factor, is right here. X plus 5 is a factor of this polynomial. Okay. Now, let's look at the second example. Second example is just that easy. You have x minus 7, so you do not have to do minus stuff. You plug in f of 7 here. What do we get? Okay, 7 cubed plus 5 times 7 squared minus 12 times 7 plus 14. What do we get? Okay, you got to use your calculator. Calculator. The calculator, you want to have a 7 cubed, which is 343. And then 7 times 7 squared is 245. And then minus 12 times 7, you have a 84. Okay, and then plus 14. Apparently, this is not going to be 0. Okay, so since this is not 0, remainder is not 0, you then can say what? X minus 7, you may mark it here, remainder is not 0. So x minus 7 is not a factor of what? F of x of f of x is this one. Because if it is a factor, it has to be 0. But we do not get 0. So then this x minus 7 will not be a factor of f of x. Okay, so the answer is what? X minus 7 is not a factor. All right? Okay, I'll see you next time.